Hey grade 10s, so we're going to shift gears a little bit here and we're going to take what we learned about distance and displacement and then we're going to move on to a little bit of a different concept, which is position time graphs. So a position time graph is a graph of the motion of an object. The position of the object is plotted on the y-axis and time is plotted on the x. That's really important, so make sure you know that every time you're doing a position time graph, position is on the y-axis, which is the up and down axis, and time is on the x, which is the across axis. So the slope of the line of best fit tells us about the motion of that object, and they can also be called distance time graphs or displacement time graphs. So first we're going to look at how to make a position time graph. So I've done all the steps here just because I have it on my computer and I can't draw it out for you, but we're going to walk through them. So our first step would be to draw an x and y axis using a ruler. This flat one across here is the x-axis and this one is the y-axis. We take our information and we label our axes and give them a correct or an appropriate title. So I've titled this graph 1. Our y is always our position, so here's our position axis, and our time is always on our x-axis, so I've labeled that as well. We take our data here and we use a correct scale to enter our data. So basically whatever increment you choose to go up by in terms of position, you have to stick with. So you don't just take these numbers and put them here. You have to pick an increment, and I picked 10 because I knew I needed to get up to 78. So my increments on my graph go up by 10 on my y-axis, and then my time just goes up individually at 1 second because my time goes up just kind of in that way by 1 second at a time, so that works. But for position, you couldn't put 0, 13, 25, 40, just because that's how it works here. You have to go up by a consistent increment. So this one we chose to be 10. So after we've got all of that labeled, you then can look at your time and your position. So our time of 0 is right here. Our position of 0 is right here. So I label my first point there. My next time or x coordinate is 1. So I look at my 1 and then I place my position at 13, so just above my 10 here, and so on and so forth until we get this straight line. And then we create a line of best fit, so you put all your dots and then you add a line to your graph. So take a look at that and make sure you know how to draw your graph. Again, time is always on the bottom, position is always along the side here on the y-axis, and you're always making sure that you're creating an increment that you can go up by. So whether it's 2s, 4s, 5s, 10s, whatever, it has to go up by a consistent increment, not just the numerical value. Okay, so let's get a little bit more into what position time graphs are. So consider a car moving with a constant rightward velocity. So rightward or positive is our direction. So this is to say right now this car is traveling at 10 meters per second in the rightward direction. So at this point they were at 0 seconds and a position of 0 meters. In 1 second they would be at a position of 10 meters. In 2 seconds they'd be at a position of 20 meters, etc. So in each of these seconds they've traveled 10 meters. So this is what a position time graph for something like that would look like. So they're moving at a constant rate. They're always traveling at a velocity of 10 meters per second. So we can see 0, 0. At a time of 1 second, they got to 10 meters. At a time of 2 seconds, they went another 10 meters and got to 20. So that creates this constant positive velocity, resulting in a straight line on our graph. So that would be if we had a constant velocity. Now if we're looking, we could have a changing velocity as well. So that means we have a position of 0 meters and a time of 0 seconds. The position then changes in 1 second to 2 meters. And then another second passes and we go up to 8 meters, which would be a difference of 6 meters. So in this time frame, from 1 to 2 seconds, they were traveling 6 meters per second. And then from 2 seconds to 3 seconds, they traveled a total of 10 meters. So we went from 2 meters, then increased by 6 meters, then increased to 10 meters. So we can tell that our velocity is changing in this graph. So when we plot it out, we have our 0, 0, position and time. So our 1 second and a position of 2 meters. Then we have 2 seconds and a position of 8 meters. Then we have 3 seconds and a position of 18. So we can see that instead of this straight line graph, when we had a constant velocity, so always traveling at 10 meters per second, here we can see that our velocity is changing. So we have a sloping line. So basically you can look at this and see, okay, our velocity started slower and then our velocity changed throughout this graph. Okay, so like it says here, motion like this would be described as a changing positive velocity, resulting in a line of changing and positive slope. Okay, so make sure you know the difference between a constant velocity and a changing velocity for position time graphs. So we're just going to look at the shape principle. So this is a lot of writing, just so that you have all these notes. So it says the shapes of position versus time graphs for two basic types of motion reveal an important principle. So we're going to look at whatever characteristic the velocity of the line has, the slope will exhibit the same velocity. So whatever our velocity is what our slope will be doing on a graph. So if we have a straight or curved velocity, let's look at that. So if the velocity is constant, then the slope is constant, meaning we have a straight line. If the velocity is changing, then the slope is changing, meaning we have a curved line. And that's what we just looked at right here. So constant versus changing. Okay, you can have a positive or a negative velocity. So if the velocity is positive, then the slope is positive, and that means it's moving upward and toward the right. So we'll just look at this as an example right here, down here. The graph is moving upwards and to the right. If you have a negative velocity, then the slope is moving still towards the right, but moving in the downward direction. So let's just look here. This is a negative slope. Notice that they're always traveling to the right. That's because time is on the bottom or on the x-axis, pardon me. So you're always having to travel in this rightward direction when you're drawing a graph. So this means you're traveling in the negative direction. This would mean you're traveling in the positive direction. So it's just a matter of if the line is going upwards or downwards. And then the last thing we'll look at here is fast or slow velocity. So if the velocity is fast, then the slope is fast, meaning that we have a steep line. And if the velocity is slow, then the slope is slow, meaning the line is flatter or shallower. So here would be a steep slope on this line, and here would be a shallow slope. So that's telling us that this object would be traveling faster. It has a faster velocity than this object per se. So just remember, the line on the graph can only be drawn towards the right because time is on the x-axis. If the line ever went to the left, so if you ever traveled back this direction, that would mean you traveled back in time, which right now isn't possible. So if we're going to describe this graph shows an object which is moving in the positive with a positive velocity because it's traveling upward. So we have our positive slope. It's a constant velocity because of our constant slope, right? We have a straight line. And it's a small velocity because it's kind of a smaller flat slope. If we compare that to this one, they have similar features. So again, constant and positive velocity. However, the slope of this graph is larger, and this larger or steeper slope indicates that we have a faster velocity. So that's how you can tell the speed, you can tell the velocity of the object based on how flat or steep the line is. Okay, so just a couple of examples here. We're going to practice describing the motion. So if I look at this position time graph, we can see that this object is traveling in the negative direction because the line is going downward. So we have a negative velocity, downward slope. It's a straight line, meaning we have a constant velocity. And I would say this is fairly shallow, so we know we have a slow velocity. So if we move on to this object here, we again have a negative velocity because we have this downward slope. Again, it's a constant velocity because this line is straight. And it's a fast velocity because this is quite steep. So that's how you can tell the difference in velocities. So use these as a good comparison if you're ever just wondering or need a reminder about how quick or slow an object is moving. So we'll do one example here, looking again, this is traveling in the negative direction. We have a downward slope. But this time, instead of a constant velocity, we have a changing velocity. So this should not say straight slope, changing velocity. We have a changing slope. So we started off with a pretty shallow velocity here. So if we're just looking at this top part here, this object was almost not changing its position at all. So it was moving very, very slow. If we then look down here, we can see how steep this part of the line is in comparison to this part up here. So that's how we know that this object would be speeding up. So again, you're looking at what your starting angle is. So this starting slope or starting angle here is very flat and then later becomes very, very steep. So we know that it's going from slow to fast. Okay? So there's a couple, oops, not zoom in. There's a couple practice options for you here. So again, thinking about the slopes, I'll just give you a couple little hints here. This is starting off fairly flat right here and then is going to be a little bit steeper. And again, this one is starting fairly flat and getting steeper. So if you can see a line getting steeper, that is indicating that the object is speeding up. So I'll let you practice those ones. And if there's any questions about any of these, just send me a message on Edmodo, reach out, and make sure you understand this because we're going to be moving on with these topics, again, building on these topics, moving through this week.